Hi folks, we're going to take a look at page 389, number 14. So let's take a look at the problem. It says Martina is planning to fly to a town 1,000 kilometers due north of her present location. There's a 45-kilometer wind. They give us a direction that it's coming from. So it's coming from north 30 degrees east. And here they say that if the plane travels at 500 kilometers an hour, what direction should the pilot head? Okay, so let's set up the problem here. So let's say this is her current location, and this is where she has to get to, okay, which we know is 1,000 kilometers away. Now, I think the distance is going to come into play because I look at part B and it says how long would the trip take, so I might have to use the distance there. But in the end, one thing that's important to remember is that this is where she wants to end up going. So this is going to represent the direction of the resultant velocity. So the resultant velocity has to be going up. Now we don't know what that is yet, okay, but we do know that there's a wind that's 45 degrees from north 30 degrees east. So here, if I draw myself a little east-west, so it's coming from north 30 degrees east, so that means it's going in that direction. So the actual vector looks like this, okay. So if that's 30 degrees, this is also 30 degrees, okay, so I guess that means this is 60 degrees, okay. Let me draw this a little bigger so that my resultant, so there's my wind velocity, and then remember that the wind plus the air velocity of the plane is going to give me the resultant velocity, okay, so tip to tail addition, okay, this is going to represent the velocity of the plane, so the air velocity, and this is going to be my what we call ground velocity or resultant velocity. Okay, so first thing I notice here is that I have this angle of 60 plus this is an angle of 90. Okay, so the angle inside my triangle is 150 degrees. Okay, it's a little awkward because it's such a thin triangle, but we can work with it. Okay, I also know that the magnitude of this vector here is 45 kilometers an hour, so I can work with that. And so the first thing we have to figure out is the direction pilot has to head. Oh, and they also give us the magnitude of the air velocity, we know is 500. Okay, so we're going to have to determine the heading of this plane. Okay, so in fact, let's sort of put in Cartesian plane to help us along, and so I think we're gonna probably try to find this angle here. I guess that would be ideal, so let's see if we can do that. Okay, so I'll just move the book away so that it's a little less awkward. Okay, so let's go ahead and try to solve this problem. So ideally I'd like to find this angle because that's the one that's near the tail of the vector that I'm interested in, okay? But when I look here, I realize that cosine law is going to be out of the question, okay? I'm not worried about sine law, so now that I have to think about sine law in the ambiguous case, because I've got an obtuse angle, I know that obtuse angles don't come into play when it comes to the ambiguous case, so I'm okay to use sine law, except I can't find this angle, okay? So I'm going to find this one up here, okay? There's going to be the theta because I know its opposite side. Here I don't know the opposite side, so there's no way to determine that angle directly. Okay, so let's go ahead and do that. So we've got sine of theta, so this is part A, okay, over its opposite side, which is going to be the 45. And then, of course, in order to use sine law, I need an angle and its corresponding opposite side, which I have here. So that's equal to sine of 150 over 500. Okay, so let's theta then is just going to be inverse sine of 45 sine 150 over 500. Okay, so let's just calculate that. Okay, so we have sine inverse of 45 times sine 150 divided by 500. And we have 2.6. Okay, so it's a small angle, but that doesn't look too surprising. So there's 2.6 degrees. Okay, so now what we have to do though is we have to determine the direction for this angle here. Now, I could find this angle because of course I know two angles, I can find the third, but what I realize here is, hey, I've got north-south from this vector plus north-south from my little cardinal plane here, and so we can use our parallel line principle that if this angle here is 2.6, then that angle there is also 2.6 degrees, okay, by the fact that here we have two parallel lines, okay, and so we can give our answer here. So the direction that you have to head is going to be north 2.6 degrees east. Okay, so there you go. There's part A. Part B now wants you to determine how long it's going to take to complete the trip. Okay, so you have to complete a distance of 1,000 kilometers, but what we need is we need the velocity at which it's going at. Okay, because remember the relationship be velocity, distance, and time. Okay, instead of remembering all three possibilities, you can just remember velocity equals distance over time. So if I want to find time, that's just the distance over the speed. And so what I'm missing is the speed of the plane. Okay, so that's step number one. Okay, so again, I think I'll just use sine law, except if I want to find this distance, I'm going to have to determine this angle phi because it's opposite to it. Okay, so phi is just going to be equal to 180 minus the angle 150 minus the angle that we found before, 2.6. Okay, so let's do that here. 180 minus 150 minus 2.6. Could have probably done it in my head, but don't want to take any chances. So 27.4 degrees, and so now we can use sine law. So the magnitude of the plane's velocity, sorry, is that over its opposite angle, which is 27.4, so sine of 27.4, and we'll use the same thing we did before. Here it'll be 500 over sine 150. Okay, so VG, its magnitude, will just be given by this. So we have 500 times sine 27.4 divided by sine 150, and we get about 460. Okay, so now I can use this formula. So the time is going to be equal to the distance, which is 100,000 kilometers, divided by the speed, which is 460 kilometers per hour. And so we get 1,000 divided by 460, which is 2.17. And let's calculate 0.17 of an hour. So 0.17 times 60 minutes is about 10 minutes. Okay, so here we have about 2 hours and 10 minutes. Okay, there we have it, both answers. Just a quick recap. So step number one was to realize that going directly north towards my destination, that represents my ground velocity, and my ground velocity is gotten by adding my wind velocity plus the air velocity of the plane, and then from there just get my diagram to work for me. Okay, that's it for this one.